Hello everyone, I'm Geetansh Aditya and today we are going to do LockPick 3.0, that is a shared lock from HacktheBox. So this is a malware analysis category and it has been categorized as hard. Now malware analysis is a really enjoying field for me. I have been a malware analyst for so long and I have been a reverse engineer also, so that's why the malware analysis contains reverse engineering because you need it. And yeah, so let's go ahead and download it. I have actually downloaded the file already, so I'll open the terminal here. Let me extract it and hack the blue, and there we go. So let us first look at the questions, and let us also read the Sherlock scenario. The threat actors of the lockpick variant of ransomware seem to have increased their skill set. Thankfully, on this occasion, they've only hit a development, non-production server. We require your assistance performing some reverse engineering of the payload in addition to some analysis of some relevant artifacts. Interestingly, we can't find evidence of remote access, so there is likely an insider threat. Good luck. So this was actually established for a workshop and it is available for free now. Yes. So the first task is confirm the hash of the malware, and the second one is XOR string utilized for for obfuscation. Third and fourth is the API endpoint, and fifth is the persistence, and sixth is the persistence ID. Okay, so we got a brief idea about the Sherlock. Now let us go back. Okay, it is now. Now we have three files here, and we have a vmem file. So vmem is a memory snapshot. So I'll be using volatility 3 for this, and I don't have the volatility here. I'll get it. So 3. Let us get volatility 3. So I'll clone it. And now I have the volatility. Now I'll use it on this vmem file because actually let's solve the first question. Hash of the malware, that is MD5. So here we have three different files. So when we look at the different file types, so you'll see that this Ubuntu client is an ELF file, that is our malware. And let us actually do the hash check of it, MD5 hash. So we use MD5 sum on Kali Linux and Ubuntu client. Okay, yeah, this has to be the answer. Yeah, that was the answer. So the next question is, please confirm the XOR string utilized by attacker for obfuscation. I think I'll need the vmem file for it. So let's just take a look at the banner. Okay, I have recently completed my memory forensics and now I am very good with it. So let's try to look at the banners of it first. So we use the volatility and vol.py and -f, the file name, Ubuntu client snapshot. We use the vmem file and we use banners. Okay, let's check if the option is correct. Yeah, so it is Linux version 5.4.0 163 generic. So one important thing that we have to know is when we are using the banners, and because we cannot, after this, if I don't have the debug symbol, then I cannot to do any other command. Suppose linux.bash, this will not work because we don't have the plugins for it, the symbols. So what we can do here is, we have to download the exact kernel version. Okay, or you can directly download the symbol files if we are able to find. So I'll be using this website, ddebs.ubuntu.com/pool/main/l/linux/ and the query custom queries will be m delimiter o equals d. So yeah, this website. So here they have mostly all of the debug symbols can be find here for all the Linux versions. So it's a really nice tool, and in my memory for 6 learnings I have been using it, so I just came back to it. Okay, so the version is 5.4.0. Let's do a search. 5.4.0 5.4.0 slash 160 dash 163. Okay, we have these few files here. We are going to take the AMD 64 deb, and okay, it started downloading. So while this is downloading, let us do one more thing here, and that is for the endpoint. So what is the API endpoint used to retrieve the key? Now this endpoint will be in our most probably ransomware itself, because it will not be manually put. I will be using Ghidra, and let us take a look at Ghidra and create a project if you haven't already, and use the code browser. And I'll import the file here, that is in the downloads Ubuntu client. Select file template. Okay. Now you can select all. I'm just gonna keep it as default. So I think analysis is complete. Now let's just I want to do a string search first. So let's do search. Go for strings. Select Pascal strings as well, and load all blocks. And click on search. So let's see what we got here. And let's take a look. Okay, I found one thing. We are using curl, and the curl init, that is for the initialization, curl set opt, that is mainly for how we define how the libcurl library should behave, and curl easy perform. So okay, we know which are the libraries are using. So this curl library, this curl function set opt, that is actually the main thing to look for. Okay, let's go ahead. I don't see any endpoint here. There are some words but no endpoints till now. Okay, there is one /connect. Okay, /connect here. Let us take a look at the function of it. And okay, so it deobfuscates and then adds to the connect. /connect is the endpoint, and so I think this will be for the API key. We'll do a trial error for it. Let me make a note of it. And first is /connect. Okay, there are actually two endpoints asked. Upload the files. Which endpoint was used? Let us take a look if we find something else. Okay, there is slash upload. Means the endpoint is somewhere obfuscated in the ransomware, but we can see these two means it will be using the same endpoint. So we have this much idea till now. Let us go ahead and add something more. Okay, this is the end of the file. So I only found these two, but okay, I'm not going through it line by line. Instead, I'll deobfuscate it dynamically rather than doing it static. So I'm going to close the code browser. Okay. And I think it's downloaded by now. It's still downloading. Okay, I'll start the video once it downloads. Okay, so the download is complete now, and I have put it in the custom symbols directory inside my download. So let us actually go to the custom symbols, and now let's make one more directory called extracted. So we have these two. Now we'll use dpkg and dpkg dev -x, then the file name, then extracted, that is the path we want to extract it to, and we'll wait. Okay, so now the extraction is complete. Now let's go to the extracted file, and let's keep going, and we have to go to the lib, then debug, then boot, and list it here. So you'll find a VM Linux file, and the next step is to use dwarf to JSON. So we have to convert this entire into a JSON file, which will be a symbol file, and we'll provide it to our volatility. So we'll use dwarf to JSON, then Linux operating system, file format. So this VM Linux generic file is actually an ELF file. You can also check it. Okay, so yeah, ELF file. So dwarf to JSON, Linux, ELF, then file name, and the output name finally. So we'll save it as VM Linux. Make sure that the output name is correct, because you don't want to mess it up on this part. 163.json. So 5.4.0-163.json. Okay, now make sure that you have enough RAM for it, because it requires a lot of RAM if you're running on the VM. Somewhere about 4 to 6 gigabits of RAM is sufficient. So let us wait for the conversion. Okay, so the conversion is done. It took about 5 minutes. So that depends on your system. So let's now, this JSON file is ready. We have to store it in a specific place in the volatility. So I'll copy it, and in our volatility folder, which we got from the Git, there's a folder called volatility. Inside it, framework, then symbols, then Linux, then paste the JSON here. Now once again, go back to the downloads folder where you have had all the files. Now I'll use the volatility again, and now use the same command linux.bash. Now it should work, because I have already put the symbols. And yes, it's working. So SSL library SSL3 dev has been installed. Okay, we got the Ubuntu client was used, and this is the input which was provided. So this is actually our string which we are looking for. So let us put it in the answer. This has to be it. Yes. Now that we have already established the exhaust string, we can actually run the program. So as I initially said that okay, we'll get it dynamically. So now we'll do it dynamically. So GDB, we are going to use GDB and -q, then Ubuntu client. Actually, I have to first make it executable. Okay, now it's executable. Now GDB -q Ubuntu client, and okay, -q, my bad. Let's do info functions. And guys, if you're wondering, I'm using a GEF plugin, so it might look different on your system. You might have different plugins, but we just have to we'll have the same work. So these are the non-debugging symbols, and I was looking for curl easy set opt, and it's not here. Curl easy. Okay, that's strange. It should be here. Okay, so I found it. So this is the function I was looking for. So I'll set a breakpoint here. Curl easy set opt. Now that I have established the breakpoint, I'll run it and provided the argument. If without the argument, this will not work because that is the deobfuscation key. And let us run it. And this is our stack. So mainly focus on here. And these are the instructions which are running. So, and these are the different registers, RIP and their respective positions. So let us now we are going to step it one by one. So right now this instruction is going to go. Then we can keep on pressing enter. Okay, so here you can take a look. Keyword PTR. So I'm assuming that this is the endpoint that I was looking for, and when this instruction will go up, means this instruction will execute, then we'll get the endpoint. That's mostly my expectation. Okay, let's see if it comes on the next step. Okay, we got it. So I'm going to copy it and I'll put it on the mouse pad and connect. So let's see if this is the answer or not. It should be. Yes, that was the answer. And similarly, we have for the upload, we just have to make it upload and it should work. Okay, that's strange. Okay, I was missing a slash. For the upload one, there is a slash. Okay. What is the name of the service created by the malware? Okay, now we are into we again have to interact with the memory for the memory forensics. So let us do that. And when we are talking about service, it means systemd. And we'll take a look at the files in the systemd. So we'll use page cache for it. And page cache dot files, and I want to grep directly, so I'll grep slash etc slash system d. And one more thing which I'd like to grep is, I don't want any of the junk, so I'll directly do service. Now let's see. Okay, it's taking a lot of time, so there will be a lot of file to go through, I suppose. We can also adjust the timestamp. So suppose we can find out the timestamp in which the one-two client was started to run. Then we can match it when the systemd service was created, and we can do another grep on it. For now, let's just use this. Okay, actually I directly saw one of the service. Yeah, here. And yeah, here also. The first service itself. So Ubuntu running dot service. That's not a real service name, so that's actually. So let's try. And okay, that was the answer. So the last question is, what is the technique ID used by the attacker for persistence? So we have to refer to the meta attack and Linux persistence service creation meta. So here, create or modify system process. Let us take a look at that. And this is exactly the one which we are looking for, because systemd utilizes dot service file, and it is this is actually the one we are looking for. This is the exact ID which was used. So let me just copy it and paste it. This should work. Okay. So guys, we have successfully solved the LockPick 3.0. It didn't take that much time actually. Thought it was gonna take a little more time, but yes, the malware analysis was okayish, and it was basically on the memory forensic side. And my take on it is, it can be, there should be more things or more hidden artifacts on it, because we hardly utilized the static analysis. So yeah, my take will be to, there should be more on the static part on it. So that's my, and one more thing which I'd like to mention is, this was actually very easy. So I don't know why it has been considered as a hard challenge, but we'll see. So until the next video guys, thank you.